Okay, today I made some pathfinding stuff. Let me demonstrate. So, this is a dig site. This is going to be like the plot for where all your crops will go. So there is corner 1 and then corner 2. And then if I calculate the area between the cubes, it'll calculate the area and then fill every whole number point with a little cube. This sphere here is used to visualize what the center is of that area. And as I can see, yep, it is in the center, which makes it look nicer, I guess. All right, and then here I have an employee who will now pathfind. One moment. Who will now, yes, who will then pathfind through and do work. Let me just get this back up. It can go any size, by the way, like that. See? Okay. Employee will now path to that. And now it will choose a point and start digging. What? Oh, these are not ignore raycast. That is probably the issue. Ignore raycast on all the children. I'm using the raycast from the terrain interactor to dig it, so that's why it has to be set to ignore raycast. Otherwise, it will block the raycast from hitting the ground, and then it won't be able to actually dig. It'll just say it dug. There we go. All right, yeah. Let me do a version with less points real quick, just to demonstrate it, or just to get it done faster. I have a divider here. Okay, well, whatever. That is now only 25, so that'll be much faster. To get the employee, I did the player model, but made him have a red shirt, like those disposable guys from Star Trek, I guess. I don't really watch Star Trek. What? Okay, well, I don't know what happened there, but that's a little weird. Yeah, and then he goes to the exit, and then that will send him to the next one after I program that in. Oh yeah. Oh, I also added a day-night cycle. This is so I can have time so that the employees can go on break. And now let me demonstrate what the scripts look like. So here is the pathfinding for the employee. I used a nav mesh for the pathfinding, and I'm just going to have it be a perfectly flat plane like the terrain. Just it'll be on the same level as the terrain, and the player won't be able to see with it or interact with it. The reason I'm doing it this way is because, one, I don't want to have to do pathfinding code myself, because I tried that in my previous game and it was annoying and didn't work. And nav meshes, every time you want to change something, you have to rebake it. And so I decided to just not rebake it or not rebake it after things have been dug. And I just made a separate plane for the pathfinding. And the holes are all going to be so small that it probably won't be noticeable if the employee is levitating a little bit above the hole they just dug, because, yeah. Now, how it works is, so they have a destination that they are set to, and they have a destination type that is, which is this kind of thing, which I will show in a moment. Then they have a list of destinations. That is so when they get to the work site can then assign them the list of destinations that it has, which would be, in this case, all those little cubes you just saw. Then there's the destination number, which is the number that they are in within the work site, or within the. It's like It's like destination 25 out of 100 in the destination list, or something like that. This is so they can know when they have reached the end and then go to the exit of the work site. Then, then there is the pause destination and pause destination type. This logs these two things. This is for when they have to go on break or refill their planter or empty the harvester or anything like that. And then they could just go back to it. Okay. I haven't really tested that part out yet, though. Then they have the break area and break time. I have, for my time manager, it's just this. It's a static script. And then I attached it to the directional light object for the scene, which controls the sun in the skybox. This is time incrementer, so it's like increment 1 every time it's time to do so, and then time wait, which is for like, like how in video games time isn't the same as in real life. Like a video game, like Minecraft has like 20-minute days or something. So yeah, it's that. So like every blank amount of seconds, add blank amount of seconds to the time. And then change the rotation of the sun to the time. And if it ever goes over 360, set it to 0. Okay, these are all the things that they can do. I have not done watering yet. I will get there when I get there. Uh, so there is the digger, which is the hoe, planter, harvester, and then there is the refiller, which is to empty out the harvester or refill the watering can in the planter. And then there is the current work site. This is so they can, or this is so that when the planter plants, or so we can make all the plants a child of the current work site. And I think maybe some other things. I will get there when I get there. Okay, so at the start, it starts coroutine timekeeper, which keeps track of. Well, I guess it'll. No, this won't keep track. Well, I guess I can eventually make it keep track of break time or something. What timekeeper does is every second try to do the thing it is supposed to do. I didn't want to use a fixed update, so yeah. Okay. What this line of code does means I can access this function below it from the inspector, and it'll be labeled, this. So, what this does is it sets the agent's destination to the destination. And then move towards first destination. This is for the task assigner to make the thing move towards its first destination. Okay, do purpose. I've got a log, or I've got a debug log here saying try to do purpose, or that I can see if it's trying to do the purpose. So it's like I can know if it's either colliding with something that doesn't have ignore raycast on, or if it's just actually not doing what it's supposed to. Or sorry, not even trying to do what it's supposed to. Okay. So, for destination type 1, it will dig and then send the and then it'll increase the destination number and then move to the next destination. If the destination is the amount of destinations it has, as in its last destination, set destination type to 0 so that it's not expecting anything when it gets there, so like it's not going to try to dig where the exit is. And then set destination to current worksite exit. So yeah, that is one of the purposes of it. And then move towards the destination. If destination type is 2, planter, and then it does the planting stuff. If it's got more than 0 plants left, move to, or set the planter worksite to current worksite. So if worksite is not equal to null, it will be added to the plant, the plant will make it a child, it will make itself a child of the worksite, and it will make any plants that it adds a list. Oh wait, hang on, I'm gonna write a note. Okay. This part is for when the harvester and the waterer need to come to the worksite. It will set their destination to be the plants. I don't know why I didn't just do the dig, I guess, because that would also work, because it's not like they have... oh well. Okay. Yep. Move, and then all that stuff. This is the code for if it needs to be, or for if it is run out of plants and then needs to refill. So pause destination equals destination, and then, yeah, destination equals refiller, destination type equals 6. This is going to be where the watering can stuff goes. Number 4, this is the harvester. So it simply just enables it because it works based off a hitbox instead of a raycast. And then increase the destination. Harvester. I'm pretty sure it's supposed to turn itself off between destinations. Yes. If holder is a person, so not a vehicle, then set the add to the carry for, so like how many things this is carrying. Carry equals parts, or carry plus equals part dot number of harvestable parts for every time it harvests a thing. If carry is greater than or equal to the holder's carry capacity, stop what you're doing and then go to the drop-off area, and then also turn this off, and then turn this off so that we aren't harvesting crops that are too young to even bear fruit or whatever, or bear corn in this case. I guess I don't know the terminology. Okay, if destination type equals 5, just turn the harvester on, set it to output. If the holder is a person, you should turn it off after you have finished outputting. Destination, so just go back to what you were doing. And then if it's destination type equals 6, this is for the refill, so it's just going to take like a split second. So after it has reached the refill, just go back. Where is... Oh, yes. Okay, so I missed saying this. If it is at its position, or if it is at where it needs to be every second, do the thing. I don't want it doing it every second, even if it's not at the place, I guess. And then it knows it's where it needs to be by seeing if its remaining distance is less than or equal to its stopping distance. I did not come up with that solution. I looked it up. Okay. This is how the task assigner works. It has a list of the dig points, and then a list of the crops, and then the site exit. Every time you collide, or every time an employee collides with, it should be this box right here, it will execute the code. So it'll see if it's an employee first. If it is, then do all this stuff. So try to get the component. This is just so I can avoid having to do a get component every time, because that's like, why would I need to if I could just do this? Okay, and then set the current work site of the employee to this. If the employee has duty type of 1, which is for digger, D-I-G-G-E-R. I did not say the N-word. I didn't say the N-word, guys. Okay. Set the how much time do I have on this video? Okay. Alright. Set the destination to be the dig points, and then set the destination type to be 1, and then set it to move towards the first destination. Same thing for all this. So this is for planting, watering, and harvesting. Okay. And then the thing that makes the area designated, or sorry, the thing that makes the area is this. So, yes. So corner 1 and corner 2, and then the cube, it will instantiate for all the points. And then this is interact point. So this is for like if you are depositing into a thing. Obviously, you're not going to be depositing into a whole area, so just deposit into the one thing. Haven't coded anything for that yet. I'll get there when I get there. This is a list of all the points. This is the points holder, which was that sphere. This stuff is to adjust the position of the points to make it all nice looking. This is the distance. This is the x distance between corner 1 and corner 2, and this is the z distance. This is the divider, so this is like if you think there's too many points, if you don't want it digging like 100 points when it doesn't need to, and it can instead just dig like 25 or something, you increase the divider until you get your desired output. Okay. Calculate area between points. X between is floor to int, which is just round down until you get to an integer. This number, which is corner 2 position, or corner 2 dot transform dot position x, or the x position of corner 2 minus the x position of corner 1, and then divide all that by the divider, and then same story for the z stuff. And then clear all the points, and then place points between corners. So clear points. For every point, destroy it, and then clear the list at the end, and then clear the list of the task assigner as well. So, place points between corners. If x between is greater than 0, I am doing it this way because not for like the placement reasons, it's more so I can use the for loop correctly. So for int x equals 0 until x is no longer less than x between, keep adding x, or keep adding to x. If z between is greater than 0, or in other words, a positive number, for every z, and same story, create a point. So to create a point, var, new point. Var is just a general variable. I think it can be kind of just anything. I don't know exactly how it works. So new point equals instantiate point prefab vector at 0, 0, 0, or at world 0 or whatever, or local 0 or something, and then 0 rotation. New point dot transform dot set parent to be, or so set the parent of the new point to be the point holder, so it can be moved around with the point holder. Add the point to the list of points. If x is less than 0, do this. Set the modifier to be negative. If z is less than 0, same thing. So new point dot transform dot local position equals vector 3, or equals this new vector 3 I just made right here for this. So x times the divider. This is so it can fill the space when it's dividing, and then it is probably because you are not changing the distance based on the divider, correcting in the correction void. So this is changing the, or so this is supposed to fill the space, and then apply an offset for x between divided by 2, so that's to get it to be in the middle, and then plus x modifier, that is an offset to get it to not be touching the corner, or to not be touching the corners, so that it's like in between them, I guess. Set the y position, set the local y position to 0 because this is a flat plane, and then do the same stuff for the z. And then set the scale to be 0.1. Then assign to the task assigner, dig points, new point. This should probably be up here. Just for logical reasons. Okay. And then fix point position. Oh yes. Okay, and then at the end of this, this is like, so I've got for x greater than 0, or for x between greater than 0, for x between being positive, for x between being negative, for z being positive, z being negative, z being positive, z being negative, do all this. At the end of this, it fixes the point positions. This is because I was having issues where it would be in some kind of weird pattern if the numbers were a different sign for the x and z between difference or distances or something like that. I don't know. I don't know why it was, and it was a different pattern for each configuration, so I'm just fixing it in post. So, what this is, set these to 0. These are about to be used. So, for every point, set the position, or set the parent to be null, so set it to have no parents. Vine boom noise, I guess. So what this does is it's so that it sets the position to 0 in the world and not 0 locally, because I'm assuming that is where the issue was arising. So, and then set the local position to point count x. I don't know if this is exactly needed, but I'm not removing it. Set it to point count x and point count z. Increase point count by 1. So this is the same situation for how it was creating a point on every whole number before, just now kind of just moving them to every whole number, I guess. And then if x is greater than z between, or sorry, and then if this current x number is greater than z between, or sorry, x between, then it will do this. So it adds to the z, so moves it to, I don't know where, and then it moves it, sorry, and then it sets point count of x to 0. So this is so it's not just a line, but is now a grid. And then point holder transform parent equals null. This is so I can set this to also be like world position stuff. Set the position of it to between the last point, or sorry, this is to set it to last point's position divided by 2. It's not between anything because I realized, well, the last point is always going to just be wherever. Yeah, it's always just going to be a positive number, so I don't need to do between. I can just do, because the other point, the first point is always going to be at 0, 0. So, set it to the x-coordinate for the last point in the list divided by 2, so half of it, and then half of the z-coordinate. For every point, set its parent to be the point holder, and then point holder set the parent of that to be the object that this script is on, which I guess is this. It doesn't matter that it's this instead of. Oh no, sorry. Set its parent to be the parent of this. Right. and then set the position between, or set the position to be between, or sorry, set its position to be based off corner 1 as the origin, and then go between corner 2 and corner 1, which is this math. So half of corner 2 minus corner 1, and then same for the z, and then that is how you get it being in the middle. Took me a while to figure that out. Yeah. Next, I'm gonna try to add, like, a way to actually place these points in the world, I guess. Yeah. I hope you enjoyed. How much time did I have? Oh, wow, 30 minutes again. Well, I hope you enjoyed this video. I hope I wasn't too rambly or whatever. I think this stuff I figured out was actually kind of neat. You might not, but these videos are more for me than you, I guess. Or, you know, they're for you, but, whatever. Goodbye.